This is the Earth Science Classroom. Welcome back to the channel. This video is on something a bit different in the channel. It's more on teaching and about how or why Earth science as a scientific discipline should be promoted and taught in not only just a couple of schools around the country, but in every school, to every high school aged student who does science. I want to talk about the perception of earth science as a discipline amongst the other scientific subjects, the classics, the chemistry, the physics, the biology, and even the newer sciences like forensics and engineering, robotics, and these other amazing sciences that have all come around. And also we got to introduce environmental science and how the environment in today's society is on everyone's conversation list, not only in politics, in social media, in documentaries and movies, but also just in conversation about what's happening to our planet. And earth science can play a vital role in encouraging and educating our young population on how the earth works, how it functions, and how it's going to directly link into the other classic sciences and also the environment and our future. So as a introduction to this video, the perception of earth science is that it is a middle school science, either 6th, 7th or 8th grade, and the fact that once a student has done a year or 2 years of earth science in middle school, then that is their education, that they're done. They can go off and not learn any more about earth. And what I see as a teacher of earth science in high school in America, and have been doing this since 2013, and have been able to write my own curriculums under the NGSS standards, and with an amazing faculty around me and an amazing administration, been able to run my classroom in a fantastic way to really promote the beauty of this science and how diverse and varied the curriculum is to give students the most engaged and improved education in the earth sciences. My main concern is the promotion of promoting of other sciences, chemistry, physics, biology, as the three main ones. Now, biology is mainly the science that's tested, with chemistry and physics being a part of that. However, earth science doesn't really get any kind of game time. It's usually on the bench, looking on at the field, watching the other sciences do their thing. And I am a great proponent of a student learn all sciences. You know, every student should have at least 4 years of all the sciences combined, if possible. And earth science is one of those 4 that really should be consistent within their education. To show you what earth science is at the high school level, I have 2 years. This is year 1. So this is usually before my freshman, my introductory course into earth science. And we begin over here in the top left, which is geomorphology, and how the landscape is formed, and how you introduce earth science with the basics of the scientific method and how to be a good scientist, and look at things like topography and mapping, contour lines, landforms, how they form different examples around the world, different climates and regions and biomes that can look into the biology of the different areas, the different regions of the planet based on continents and based on climatic conditions, elevation, spheres and connections, how the world has these different spheres and how they connect, mechanisms, the feedback that is especially involved with things like climate science, and looking at historical geology and historical earth science and how these feedback mechanisms work together to form our planet and how things work together. Then we go into geology, the main crux of the year, which would be starting off with mineralogy and minerals, petrology and all things rocks. So look at the 3 rock types, and that leads into nicely the Earth's interior, the different layers, and look at the crustal deformation and how that works in with plate tectonics. How we look at volcanology and subduction and seismology as a package deal as a result of what happens with plate tectonics and the explanation of that. And we can also look up into the principles of geology as well. Hutton, Steno, those gentlemen that pushed the understanding of how the Earth works and the age of the Earth into modern concepts and ideas. Then look at the atmospheric dynamics and atmospheric science, looking at the layers of the atmosphere, the GCMs, how the northern hemisphere, southern hemisphere work with wind patterns and atmospheric cells, the Ferrel cell, the Hadley cell, and then the polar cell, looking at how the lowest layer troposphere works with dynamics, and how we look at mid-latitude cyclones being in North America, and obviously in Europe and other parts of the world. You are right in the way of the mid-latitude cyclones, the difference between the hot air from the equator mixing with the cold air from the poles. Looking at cyclonic systems and introduce them to both anticyclone and cyclonic systems, high and low pressure, and looking at basic climate dynamics and what creates climate on the Earth. Then we go into astronomy. Now, astronomy goes into looking at the ancient astronomy and how we got to our point of knowledge and education in this subject through various advancements and amazing people. Looking at our place in the solar system and looking at the sun dynamics, the different dwarf cloud and the Kuiper belt, and looking at then further afield into space and galaxies and different types of matter and black holes, and the origin of the universe with the Big Bang Theory and different other theories as well that come into the galaxies. And we can bring in modern things like Elon Musk and SpaceX and how they are going to try and travel to the Mars. And so this is a very nice year one way to introduce the topic. As you can see, it is extremely varied, and you can bring in different levels of physics and chemistry wherever you want into every part of the Earth science curriculum. You even involve math in certain levels of the algebra, the formula to figure out different principles and different theories that each section provides. Then we have year 2, and this is usually offered for upperclassmen in high school, which is going to be grade 11 and 12, students that are going to be between the age of 17 and 18. And this could either be a separate standalone subject or year, or it could be a second year that adds on to their earth science as a freshman or sophomore. So this year 2 includes again 4 main sections. First one will be hydrology and the process of water on the surface of the earth, water cycle, and looking at more stream flow and surface reservoirs, looking at groundwater and how the flow of groundwater creates aquifers and caves, linology, which is the study of streams and lakes and rivers, and looking at the atmospheric movement of water as well, so wind and water vapor and condensation levels, and again linking up to the atmospheric science in year 1. Next would be soils and geologic history. Now this is important because you can really tie in the rocks and the rock cycle back into this, also with Hutton and geologic time, and looking at different theories and principles of geology. Looking at mining, looking at surface processes, looking at the soils and latitude, looking at how we as a species have only occupied a very short time in Earth's history, and how we have advanced, how we have affected the planets for only a short time of only being here. So we can look at different anthropology, geography, looking at environmental science and engineering, how we can link in and cross-cut other subjects into this unit. Then we're looking at oceanography as our third part. Now this is amazing because the Earth is pretty much 70% water, and the understanding of how the oceans control climate, control heat movement, both on surface flow and deep water flow with gyres and eddies, and looking at the ocean-land interaction, the coastlines, and looking at ocean chemistry and how it can be changed. Again, we can bring in lots of chemistry, lots of physics, bring in some math, and bring in the application of this and seeing how we affect the oceans, which again is environmental science. So the knowledge of how the oceans function is imperative to know how we can change those oceans, both for a negative and a positive way. And last is extreme weather. Again, this links into climate change, links into history, links into anthropology and our species, where we colonate, where our cities are, in relation to we're close to the ocean, we're close to various natural disasters that occur, especially in USA. The last 10, 15 years, we've seen an increase in wildfires, increase in flooding, increase in hurricanes and where they make landfall, increase in drought in various areas of the country, a decrease in surface water levels and freshwater availability. So it's going to be a fantastic way to end and culminate all of the knowledge of how the Earth works to how it creates this extreme weather. So thermal energy, frontal systems, and droughts and flood, how the climate and atmosphere creates these conditions. Cold weather systems like lake effect snow, which can bury buffalo in 8 feet of snow over a short period of time, thunderstorms and tornadoes and supercell creations, again, mid-latitude cyclones, looking at the hurricanes, cyclones and typhoons and how they develop and how they can cause disastrous results in different parts of the world, and how we can track them, predict them, and hopefully evacuate the right areas at the right time. So these, both year 1 and year 2, all link in constantly to chemistry, to biology, to ecology, to anthropology and the more social sciences, the history element to it. You can even look into, obviously, environmental science and that part and how it fits into that. And we can also discuss in great detail climate change with more knowledge of how the Earth functions as a system to figure out where it's going in the future with the change in composition of our atmosphere and our oceans. So as a overview of why Earth science is so important to be taught in high school, especially from grades 9 through 12, especially in the United States, is all those different things I discussed in year 1 and year 2 and different topics and connections. They can't be covered at the right level, the right rigor, the right scientific detail in middle school, because unfortunately students don't have the background, they don't have the chemistry or physics knowledge or biology or ecology knowledge that they would get in high school to apply and link into the earth science topics, because everything happens besides astronomy and astrophysics, looking at all those classical sciences of chemistry, biology and physics being applied on Earth, under Earth's physical and chemical constraints, and how these classical sciences all relate back to earth science, and how earth science can combine all these sciences together to form a knowledge of our planet, both physically, chemically and biologically. This is the Earth Science Classroom. Thank you for watching. I hope you enjoyed the content. Check out more videos on our channel, and don't forget to subscribe. Thank you again.